The Industrial Revolution is often described as the most important economic turning point since the rise of agriculture, and that comparison is not exaggerated. Agriculture allowed humans to settle, store surplus food, and support larger societies. Industrialization did something equally profound in a different domain. It changed the limits of production itself. Before this transition, most goods were made by hand in homes or small workshops, and output grew slowly because it depended on manual labor, traditional tools, and local energy sources. After industrialization, production increasingly shifted toward machines, powered systems, and factory organization, which made output faster, cheaper, and more predictable. This was not a single invention and not a single year. It was a long transition in how economies functioned. The importance of that transition is visible in what followed: sustained growth in income, expanding urban populations, and a new expectation that each generation could produce more than the previous one. In other words, the Industrial Revolution did not merely improve old methods. It changed the underlying logic of economic life from periodic growth to continuous scaling. The first phase began in Great Britain around 1760, and Britain's role was shaped by a rare combination of conditions. It already had strong commercial networks, active trade routes, and legal institutions that made private investment relatively secure. By the mid-18th century, Britain's income per person was above the world average, which meant demand existed for consumer goods and capital existed for experimentation. Geography helped too. Navigable rivers, accessible ports, and coal deposits gave manufacturers logistical and energy advantages. But resources alone do not create a revolution. What mattered was that these factors interacted. Entrepreneurs could raise capital, deploy it in mechanized production, and reach domestic and overseas markets at scale. Once early mechanized operations proved profitable, imitations spread quickly. Competing producers adopted similar methods to avoid being undercut on price. That pressure drove a feedback loop: higher productivity lowered costs, lower costs increased demand, and larger demand justified more mechanization. Britain was not uniquely inventive in every domain, but it was uniquely positioned to turn invention into a self-reinforcing production system during this period. Textiles became the first major sector to industrialize, and this was critical because textiles were already central to daily life and trade. Early mechanization in spinning and weaving transformed a high-demand industry where small efficiency gains scaled into large economic gains. In pre-industrial textile production, much work was distributed across households and small artisans, creating bottlenecks in speed and consistency. Mechanized spinning in particular removed one of those bottlenecks, allowing thread production to catch up with weaving demand. As mills expanded, textile production moved from dispersed labor toward concentrated factory labor. This shift changed not just output volumes, but management structure. Factory owners organized shifts, supervised work rhythm, and invested in buildings and machinery that required constant utilization to remain profitable. Textiles then became dominant in employment, output value, and capital investment, proving that mechanized mass production could outperform craft production in key consumer markets. Because textiles had broad demand and repeat purchasing cycles, they offered an ideal testing ground for industrial methods. Success there gave investors confidence to apply similar principles to other sectors, accelerating the broader industrial transition. Energy transition was the hidden engine behind this transformation. Traditional economies relied on human and animal labor, wind, wood, and water, all useful but constrained by location, climate, or biological limits. Water power supported early industrial mills, but it tied production to river sites. Steam power changed that constraint. By converting coal into mechanical energy, steam engines allowed production to expand where market access and transport made sense, rather than only where flowing water existed. Steam adoption was not immediate everywhere, but once engine reliability improved and costs fell, it enabled larger factories, denser machine layouts, and more predictable throughput. Parallel advances in iron production and machine tools were equally important. because industrialization required durable, precise, and reproducible components. Better iron and better tooling made machines stronger, easier to replicate, and easier to maintain. Chemical manufacturing improvements also expanded what could be produced at scale. The key point is systemic. Steam, metallurgy, and tooling formed a technical stack. Without that stack, industrial production would remain fragile and local. With it, economies gained a platform for compounding productivity increases over decades. The factory system was not simply a larger workshop. It introduced a new social and economic discipline. In home-based production, families often controlled their own pace and task sequence. In factories, time became centralized and measured, with workers synchronized around machine operation and shift schedules. This raised output but reduced labor autonomy. It also altered skill structures. Some artisanal roles declined as machine processes standardized tasks, while other roles emerged in maintenance, supervision, and mechanical adaptation. Capital intensity rose sharply because machinery and buildings required high upfront investment, making production more dependent on finance and planning. If supply chains failed or demand weakened, fixed costs still remained. That risk pushed owners to pursue scale and market expansion, which in turn deepened industrial organization. Factory concentration also changed settlement patterns, drawing workers into urban centers where jobs were available. Over time, this reorganization of work contributed to class formation, labor bargaining, and new political pressures around wages, safety, and regulation. So the factory was not only a site of production. It was a new institution that reshaped relationships between labor, capital, and the state. Industrial growth in this era was dramatic, but it was not linear. Historians debate exact boundaries of the first industrial revolution because sectors and regions moved at different speeds. In Britain, rapid mechanized textile adoption accelerated in the 1780s, while strong growth in steam power and iron intensified after 1800. Then came a notable slowdown in the late 1830s, when early innovations matured and market expansion became less explosive. This phase is important because it shows industrialization follows waves, not permanent acceleration. Once first-generation productivity gains are absorbed, economies need complementary technologies and institutions to unlock the next leap. During this slower period, innovations like the electrical telegraph began spreading, especially in the 1840s in Britain and the United States, but they did not immediately recreate earlier growth rates across the whole economy. The lesson is that major technological transitions include surges, plateaus, and re-acceleration points. Understanding these rhythms helps explain why industrial societies periodically experience both optimism and anxiety. Breakthrough periods promise rapid gains, while consolidation periods reveal bottlenecks, inequality tensions, and the limits of existing infrastructure. By the early 19th century, mechanized textile production and related methods had spread from Britain to continental Europe and the United States, but diffusion was uneven. Countries differed in capital availability, education systems, infrastructure, and political priorities, so they adopted industrial techniques at different speeds and in different forms. Some regions emphasized rail and heavy industry early, others focused first on consumer manufacturing. Despite this variation, the overall trend was clear. Industrial methods expanded beyond their British origin and began restructuring global manufacturing geography. Before this period, large shares of world manufacturing had been associated with economies such as China and India. After industrialization spread through Europe and North America, manufacturing concentration shifted toward Western Europe and the United States. That shift was not only technological. It also reflected trade structures, financial power, imperial networks, and strategic control over shipping and raw materials. Industrialization therefore had distributional effects at the global level, not just within countries. Regions that industrialized early captured productivity and military advantages, while late industrializers faced higher barriers. The resulting imbalance influenced global politics, development paths, and the modern hierarchy of industrial power. The social consequences were massive and often contradictory. Industrial output growth supported population expansion and eventually rising average incomes, but early urban industrial life could be harsh. Rapid city growth outpaced sanitation, housing quality, and workplace protections. Many workers faced long hours, repetitive labor, and exposure to unsafe environments. This creates one of the central debates in industrial history: when did living standards truly improve for ordinary people? On long timelines, sustained growth in average income is clear. On short timelines, benefits were uneven and delayed. Some groups gained quickly from profits, commerce, and skilled technical roles, while others endured decades of instability before reforms improved conditions. Over time, pressure from workers, public health crises, and political movements led to institutional changes, labor regulation, infrastructure investment, and broader social policy. Those reforms did not occur outside industrialization, they were partly produced by it. In that sense, the revolution forced societies to invent new governance tools for a high-productivity but high-disruption economy. The modern debate over growth versus fairness begins here, in the gap between aggregate progress and everyday lived experience. After around 1870, rapid growth returned through what we call the Second Industrial Revolution. This phase built on earlier mechanization but introduced new scale through steelmaking advances, electrification, and refined production systems. Steel reduced structural constraints in transport and construction, enabling stronger rail networks, larger ships, and more ambitious infrastructure. Electrical grid systems expanded flexibility in power distribution and, over time, changed factory design and urban life. Mass production and assembly line principles reduced per-unit costs while improving consistency, making manufactured goods available to broader populations. Large-scale machine tool production increased precision and interoperability across industries, reinforcing industrial ecosystems rather than isolated factories. The first industrial phase proved machines could transform output. The second proved integrated systems could transform entire national economies. Firms grew larger, management became more formalized, and industrial competition became increasingly international. This re-acceleration also showed a recurring pattern: when foundational technologies are combined with logistics, finance, and organizational innovation, growth can jump to a new plateau. Industrial revolutions are therefore less about one technology and more about coordinated layers of change. To understand why the Industrial Revolution still matters, focus on the mechanism it introduced: compounding productivity through system integration. Hand production was replaced by machine production, local energy constraints were reduced by scalable power, fragmented workshops were reorganized into factories, and eventually factories were linked into national and global industrial networks. That mechanism did more than raise output. It changed expectations. Societies began to assume that technological progress could continuously raise living standards, even if unevenly and with conflict. It also changed policy priorities, pushing states to engage with infrastructure, education, labor law, and public health as economic variables rather than purely social concerns. The period's contradictions remain with us: growth and inequality, innovation and displacement, efficiency and vulnerability. Today's debates about automation, artificial intelligence, energy transition, and supply chain resilience echo questions first sharpened during industrialization. Who benefits first? Who bears adjustment costs? What institutions are needed to convert invention into broadly shared progress? The Industrial Revolution did not provide final answers, but it created the framework in which modern economies still operate. In that sense, it is not finished history. It is the origin story of our present. If you found this helpful, please like this video and subscribe for more explainers.